Hello, everyone, and thank you for being here. My name is Hassan Farbi, and I'm honored to present our research paper, which is EcoDetect Lightweight Real Time Recyclable Waste Detection using YOLO V11N trained on LLM guided synthetic data. So, this work has been accepted for publication at 28th International Conference on Computer and Information Technology, and it was organized by IEEE Bangladesh section. So today I'll be sharing the motivation behind the project and the methods we used and why our findings matter for real world waste management. So right now the world is drowning in waste, and the crazy part is only 13.5% of global waste actually gets recycled. So the rest ends up in landfills, rivers, and oceans. So it's not just an environmental issue. It's a system that's failing millions of people in high density cities. So on the other hand, you can see that the manual sorting is the biggest bottleneck here. It's slow, inconsistent, expensive, and honestly unsafe. So, workers handle sharp metal, dirty plastics, and harmful materials daily, which is not good. So, the real question is how do we automate waste detection in a cost effective way that even low resource countries can deploy? So current solutions struggles with the major blocks, three major blocks basically. So the data scarcity, so it is like West datasets are tiny, biased, and not diverse. That is about the data scarcity. Then we had uh, edge constraints, which is smart beans are, and mobile robots can't run giant models. That's a problem. Then we have real world complexity, which is lighting, clutter, object deformation, because the real world is messy. We all know that, right? So EcoDetect will also tackle this type of thing, and we will see. So instead of collecting thousands of real photos, uh, we went fully synthetic. So that's our strategy here. We generated uh, over 1,800 plus photorealistic waste images using LLM engineered prompts. Then no real samples were used during training here. So which avoids leakage and forces the model to generalize, right? So the dataset includes three recyclable classes here: paper, plastic, aluminum. And because we control the generation pipeline, we introduce massive variation, which is clutter, textures, deformation, backgrounds, shadows. So everything the real world throws at you, everything was there. So we used LLM to engineer highly specific prompts, which was very necessary for this project, for this research, because it's a major part here. For example, we didn't just ask for a bottle. We asked by using detailed prompts, which is shown below. As you can see, there's a prompt here. This is a detailed prompt that we used. So this synthetic first approach removes the need for months of manual data collection. So this is one of our noble part of this project. So, and if I talk about the training was done entirely in Google Colab using GPU runtimes like T4 and A100. So we loaded the dataset from Drive after like doing the stuff in RoboFlow. We like loaded the dataset from Drive, plugged it into the YOLO V11 and pipeline, and trained using a simple command structure, which is shown here. Throughout the process, we monitored loss curves, MAP, precision, recall, everything was monitored carefully. And we also used different seeds to understand the quality of what we're doing. And once training converged, we exported the best model weights directly for edge deployment. And we also did some prototype experiments with a robotic arm and a rover. We used a rover, even though it is not fully complete, but we did those prototype tests as well. So now our pipeline, which is our main methodology, if we talk about that, like our pipeline has five main steps. LLM based prompt engineering to generate diverse synthetic scenes. That was the first thing we did. Then we did the annotation and augmentation in RoboFlow. Afterwards, we did the dataset splitting for balanced training, right? Then training YOLO V11N and optimized for lightweight inference. That was our fourth stage. And in the end, we tried the zero shot real world testing to check our generalization, and it works so well. So this stacks makes the system scalable, reproducible, and across different waste categories. So when we tested EcoDetect on real waste samples, even though it trained entirely on synthetic images, we got strong results, which is shown here. MAP was at the rate 0.5 was 81.1%, which is really good because our the whole training was happened with the synthetic, and we're testing with real. So this is mind blowing thing here. Then we had the precision 78.9%. We had the recall 76.5%, and the model size was only 2.59 million parameters. And that means EcoDetect is not just accurate; it's extremely light, making it deployable on small processors, smart bins, and low cost robots. And of course, we didn't solve everything because there will be gap, and we had it as well. So the sim to real gap still hits performance in harsh lighting. So and also the paper versus plastic sometimes confuses the model due to similar shapes and textures when crashed. So to push further, we are exploring like integration with SLAM enabled rovers for autonomous collection, adding glass and e-waste to the dataset, quantizing the model for ultra low power microcontrollers. So these are the things. These are for our future work. And if we discuss about the conclusion, EcoDetect proves three important things here. Synthetic data works. LLM guided images can train reliable detectors like YOLO or any other object detection model. And lightweight models are enough. YOLO V11N hits high accuracy with minimal compute, and the pipeline scales. We can extend the system to new waste types or new environment instantly, right? If cities want cheaper, cleaner, and smarter waste management, synthetic first AI like EcoDetect offers a realistic path forward, right? And we can see that. So that was all about our presentation, and you can access our dataset and code through the QR code. If you scan it, you will be able to view it. And thank you for your time. We really appreciate it, and we're hoping for the best in the future. Thank you so much.